This question is number 2 in assignment 3 in unit 3 for math 1 to 2. That's on discrete probability distribution. Here it says a random variable has the following probability distribution: x, 5, 10, and 15. And the probability of 5 is 3z. The probability that x is equal to 10 is z. And the probability that x is equal to 15 is z. So the question now says where z, that's supposed to be z, because that's a modification of a previous question. Where z is a constant, find the value of z, not t, z, the population mean, and the standard deviation. So we've got to find the value of z. Now we know for any probability distribution, the sum of the probabilities must add up to 1 and only 1. Okay, so we can form an equation with the probability values, and that will give us a means to solve for z. So here we have used the fact that when you sum up the probabilities for a probability distribution, the sum must be equal to exactly 1. So we have 3z plus z is equal to 1. So here we have got a linear equation with one variable, hence it is solvable. So we got 3z plus 1z. If we don't see a coefficient, then there's an invisible coefficient of 1. 3z plus 1z plus 1z. That will give us 5z is equal to 1. And now to solve for z, we simply divide both sides by 5. So 5z divided by 5 and 1 divided by 5. What you do on the left side of the equation, you must repeat the same thing on the left side of the equation. So 5z divided by 5, that will give us a z. It means that 5 has been cancelled out. So we are left with z is equal to 1 divided by 5, and 1 divided by 5, we all know is 0.2. So z is equal to 0.2. So now we can complete the probability distribution. 3z, that will be 3 times 0.2. That will give us 0.6. Z is 0.2 and z is 0.2. And as you can see, 0.6 plus 0.2 is 0.8 plus 0.2 is 1. So now we have solved for z. Now we can find what is the population mean mu. And we have done that in question number 1. So we know the formula, so we can just repeat the same thing for these values. And also for the variance, because you must get the variance before you get the standard deviation. The standard deviation is the square root of the variance. So you can get the mean and the variance one time using the table of question number 1. So to preserve these values, I simply added another sheet. So I'm going to copy this information and paste it in sheet 2. Let's see what happens. Right. So I transfer these formulas. So what I'm going to do basically is to change the values. For x, we've got 5, 10, and 15. Change to 5. And what you're going to see now happening is that these values will be modified because they are linked with columns A and B. So we've got 5. You can see values are changing already. Okay. 10. 15. So these are the X values. So the probability values are 0.6, 0.2, 0.2. Okay. So our mean is equal to 8. And our variance is equal to 28.11. So the standard deviation now, okay, so that will be B, and this will be C. Not yet, that's just the variance. To get the standard deviation, we go to square root the variance. So let's not do that a later yet. So C now is the standard deviation. Let's call this sigma is equal to. So we can do that right here. Actually, I can delete this 8 and use this cell. Just type the formula equal is equal to C5, and then the 8 will come. So what I want to do here now, I want to square root. So I type equal and square root this value there, value D5, here it is, close bracket, that will be the standard deviation. Square root, not square, square root. Square root. Ah, look at the square root. Good. Square root D5. Square root D5. Let's see what happens there. Right, I'm looking for the decimal point. 5.301924.179. We can modify this to edit the number of decimal places. Properties, I guess. Okay, well, we'll leave it first. We'll leave it so for now. 5.3019.